Alright, back with exercise 22D, question 5. So we've got a metal strip of length 1 metre being deflected by y metres at the end at a distance of x metres from its fixed end. So it's fixed obviously way back here at the start, and then as x moves along it bends, and it's known that the second derivative of y in terms of x, great, equals negative 1 over 10, 1 minus x all squared. Terrific. Find y and dy dx when x equals 0. These are actually slightly easier questions. They're talking about only the point where x equals 0. Well, what would be the displacement? Y when x equals 0 must equal 0. Why is that? Well, because clearly there's no deflection at the fixed point. So at that point there is nothing to worry about. Also, dy dx, at what rate is it changing? Well, at the start there, if I drew a tangent to that curve, it would be horizontal. Dy dx is also going to equal 0 at x equals 0. Later on, it's going to change. You can see it's going to get more negative here, or if I was pushing up, more positive, you know, but there's going to be a deflection. But right at the start point where it's fixed, there's no change. It's fixed there, so there's no deflection, and there's no rate of change of deflection. That's the first bit. Let's go ahead to the more challenging bits. I know it only asked for part A, but let's do these other bits anyway, just to make sure we're okay with them. So how do I go about the rest of it? So find the function y of x. Well, all I've got so far is d squared y over dx squared. So what about we first find dy dx, and we'll go from there. So dy dx is going to be the integral of d squared y over dx squared. So negative 1 on 10, 1 minus x all squared. 1 minus x all squared dot dx. Can put the constant out the front. Doesn't really matter in this case, so let's just put negative 1 on 10 there. This thing is a derivative. It must have come from 1 minus x to the power of 3. But if I went ahead and did the derivative of that, then we've multiplied by 3, so I've got to make up for multiplying by 3, which means multiplying by 1/3. Or just dividing by 3, you could go over 3. And also the derivative of that inside of the brackets is negative 1. So I'd have to have a negative there to cancel out that. Plus c. So what we end up with there, the two negatives cancel out. And I've got 1 minus x all cubed on the numerator. In the denominator, 3 tens are 30. Plus c. Now, we know that when x equals 0, dy dx should also equal 0. So that's going to let us calculate c. So 0 is going to equal 1 minus 0 cubed divided by 30 plus c. 0 equals 1 over 30 plus c. So negative 1 over 30 equals c. And if we come over here for more working, so I've got dy dx, that's a y, equals 1 minus x all cubed over 30 minus 1 over 30. Now I want to go ahead and find y. What am I going to do? It's the same procedure again, isn't it? Do the integral, figure it out from there. So y is going to equal the integral of 1 minus x all cubed over 30, but I didn't write the all cubed yet, minus 1 over 30 in terms of x. We're doing it in terms of x. It's good to have the brackets around it there. Go ahead and integrate again. So the 1 minus x cubed must have come from 1 minus x all to the power of 4. I was already over 30. Now remember, would have to multiply by 4 if I did the derivative, so I've got to divide by 4 to make up for that. The derivative of the inside is negative 1, I've got to divide by that negative 1 as well. So all of those would cancel out. Over here, negative 1 over 30 must have come from negative 1 over 30x, which I'm just going to write as negative x over 30 plus c. And we've got an expression for y. Just got to figure out that c. Again, we know way back at the start when x equals 0, y is equal to 0. So therefore, 0 is going to be equal to 1 to the power of 4 is 1. So it's 1 over negative 120, so just negative 1 on 120. When x is 0, this fraction is going to be 0 plus c. So 1 over 120 equals c. And y is equal to 1 minus x to the power of 4 divided by, where do we have it? 120 there. Whoop, and that was a negative, wasn't it? So negative 1 minus x to the power of 4 divided by 120 minus x over 30 plus 1 over 120. And there you have it. Part C, determine the greatest deflection of the metal strip. Let's go over here and do part C just up there. Well, the greatest deflection is going to be at the end point, isn't it? So let x equal 1. Therefore, y at 1 equals, and we just go ahead and calculate that. Well, this first bit's going to be 0, negative 1 over 30 plus 1 over 120. So that's negative 4 over 120 plus 120, negative 3 over 120, negative 1 over 40. We've got some units somewhere. Is deflected by y meters. Negative 1 over 4 meters would be the deflection when x is 1 meter. And there we have it. All right, see you in the next one.